So I know I gave some of you an opportunity last week to get a head start and finish this. So even if you are finished with this, just follow along and just make sure that we did it right. What is the equation of the parent function f of x? So here on the diagram, there's two different functions, f of x and g of x. This process of getting a graph and turning it into an equation, that's something called a regression. Like this year, whether or not you've called it that, we've done linear regressions. You've gotten graphs of lines and written the equation that goes with it. The same can be done with a parabola, but we haven't done that. You can do them with cubic functions. You can do them with any type of a function where you take a graph and turn it into an equation. Now, the process of doing that with an exponential function, it's not so much that it's time confusing, but it requires the use of algebra. This is more of an Algebra 2 skill. So, how in depth I should be getting, I don't know. So I'm just going to keep it watered down. I'm going to keep it pretty as simple as possible. So what I would do is, the first thing I'm looking for, here. Remember that in a parent function, no transformations have occurred. This is before you do any flips or stretches or anything like that. What type of a function does that look like? Huh? Yeah, it looks like a decay, right? So when I'm coming up with the f of x is equal to something to the x power, that's something that's in that parentheses. I know it has to be a proper fraction. It has to be in between 0 and 1. All right. Well, again, this is not something that like a student in Algebra 2 I would expect them to do. But here in Algebra 1, if we keep it real simple, what I would want to do is see what's happening when that x is 1. Because what is any number to the first power? Is itself. So that's going to be my first look. Okay? But being that it's a decay, when you come over to x being 1, well, that's the y that goes with there is in between 0 and 1. I don't know what it is. You can't just assume that it's 1/2. So then the smarter thing to do is say, well, hey, look, since I already know it's a decay, and Mr. Romero had already suggested that with decays we use negative, instead of looking at positive 1, let's look at negative 1. And if we look at negative 1, what's the output? What's the y when x is negative 1? 2. So that means that if this something that we're looking for to the negative 1 power gives you 2, well, if that negative causes there to be a reciprocal, what's that base there? What it isn't 2. It's like, what is 1/2 to the negative 1 power? It's 2. Now, what transformations map these two together? Well, that's harder to do than, we've done transformations before with parabolas. Parabolas are a little bit easier because most of the transformations you can tell by looking at the vertex. But exponential functions don't have a vertex. So I think that's why, and I've never even really seen this type of stuff done before, but you see how they have these points here that are kind of highlighted? Right, you see that? Regardless of the points, what's the obvious transformation that's occurred? What's the most obvious one? A reflection, yeah, there's definitely a reflection. This definitely flipped over the x-axis, so we have an x-axis reflection. Okay. The hardest to determine would be if there's a stretch or not. Translations usually aren't that difficult, and especially like, yeah, it would be difficult with an exponential, but they gave you these points. But if you see, like, you have 2 points that are directly above each other, another 2 points that are directly above each other. So, like, it doesn't look like anything happened left or right. It doesn't look like we have any type of horizontal translation. But it is possible that we had a vertical translation. It's also possible that we had a vertical stretch. So how would you know the difference? Well, I guess it'll be a little bit of trial and error, but because the people I was helping with this last week, I had to kind of do trial and error also. But what I would say, look at these 2 points, right? To get from one to the other one here, it's up one and left one. But on this other one, when you go left one, you go down two. Now, the reason you're going down is because the flip occurred, but the other reason is because there was a stretch. So there was a vertical stretch. So when you start writing that out for the equation of g of x is equal to, that would make this look like 2 to the 1/2, oh, sorry, negative 2 because of the flip. Negative 2 to the 1/2 to the x. We know that there's no h because it doesn't look like it, like since those points are directly aligned one above the other one, it doesn't look like it's shifted left or right. But we still don't know for sure if there was a vertical translation, if it went up or down. So what I would just do then to try to check is plug in these 2 points here that are part of g of x to see if they give us an equivalency. So like here, this first point, what's that? Here, this point is 0, -2. If indeed this function is correct, when I plug in a 0, I should get a -2. If this function is correct, when I plug in a -1, I should get a -4. If it is, we leave it. If not, then we got to see if there was some type of a vertical translation. Let's plug in a 0. What's anything to the 0 power? It's 1. What's 1 times -2? -2. So this one checks out. Let's try the other point. What's 1/2 to the -1 power? +2. What's +2 times -2? -4. This checks out also, so it doesn't look like there was any type of a vertical translation. Those look like the only 2 transformations, and therefore that's the function g of x. Caleb, can you take the book right off the desk, please? Any questions there? State whether these equations are exponential growths or decays. I would hope you can get this 100% of the time now. It's about as easy as it gets. The first one, is this a growth or decay? Why a growth? Why growth? Yes, Jada. So it's not about the base being positive. The base is greater than 1. Base is greater than 1. The base has to always be positive. If the base is negative, it wouldn't look exponential. There would be what are called discontinuities. The graph would jump around too much. The base always has to be positive. How about the next one? Growth or decay? Thank you. Why decay? Base is less than 1. Sure. How about the C? Growth. Wait, but mister, it's a fraction. Yeah, but that's an improper fraction. 3/2 is greater than 1. Growth. How about the last one? Decay. 0.5 is less than 1. That's a point. Base. I would hope by now you know how to identify which numbers. Any questions on that one? So then number 9, what is the... Jada, you okay? You have this like pained expression on your face. Oh. What is the equation of the parent function? And then what, so this is kind of like the one that we just did for number 7. So if we look at the parent function f of x, this looks like a growth. And when x is 1, y is 2. So that would, somewhere to type this. Go ahead up here then. So let's just say f of x is equal to 2 to the x. The base is 2. I can tell by looking there. Now let's look at the transformations. Has a flip occurred? Has any type of reflection occurred? No. So A, I know A has to be positive. Okay. Then again, they gave us these points highlighted, which usually is not supposed to mean much, but fine. Oh, you know what? I'm an idiot. You know what? I just thought of something because I'm about to use it now, and I'm like, why didn't I think about it on the last one? What would have been an even better way to figure out that no vertical translation had occurred? On this number 7 here, because I'm about to do the same thing right now, but I didn't even think about it because of the way that the graphs were located. It's my fault. What we spent the last part of this number 7 here trying to figure out if a vertical translation has occurred. The vertical translation should be the easiest one of all, and I left it for the end like a fool. This should be the easiest one because what gives away what the vertical? Okay, better yet, what transformation number represents a vertical translation? Well, K does, but then yeah, and then where do we find K? We can find K by just looking at it, the asymptote. So yeah, the parent function had an asymptote of 0, but guess what? So did g of x. That's going to be K. So when I come over here, to this next one, well, I can't really tell where the asymptote is for g because it looks like it keeps on going. But assuming that it's going to be at an integer, the only asymptote for g I can think of would be that one there, right? So it looks like K is going to be -3. And then we can kind of confirm this by looking at the pictures at the points here to get from one point to the other. 1, 2, 3 down, and then 1, 2, 3, 4 to the left. And the same thing for the other one. So assuming that those 2 points correspond, down 3 and left 4, the only thing left to figure out was A, but we know that A is not going to be negative because there was no reflection. And then if you just count, think of it almost like a slope. This is 1 to the right, 1 up. This is 1 to the right, 1 up. So it doesn't appear that there was any type of a stretch. What transformations then occurred here? What transformations occurred here? Yeah, we just had 2 translations. Translation left 4. Translation. So what's the equation going to be? G of x equal to, if they ask you to write an equation on tomorrow's test, don't forget to write the first part of it. The base was 2. A is 1, so there's no need to write an A in front. So 2 to the x plus 4, then a bigger -3. Plus 4 is part of the exponent. -3 comes after. If you have any questions, raise your hand. All right. So, see, like the other teachers teach you to graph more by substitution. They teach you to use these things in substitution. Like plug in a 0, plug in a 1, plug in. And if you want to do that, go ahead. But the way I showed you, you can more come up with your own numbers. So I'm going to delete the numbers they're putting on that they put in. I'm going to use my own. Now this first function that I'm graphing on number 10, what's the A here? 1, what's the H? And what's the K? So that means that this is a parent function. There's no transformations there at all. All I have to come up with is the parent points. Is that a growth or a decay? It is a decay. And what numbers did I recommend using for decays? 0 and negative. So let's put in 0, -1, -2, -3. What's 1/4 to the 0 power? what's 1/4 to the negative 1? What's 1/4 to the negative 2? 16, good, and then 1/4 to the negative 3 is 64. So it doesn't look like a lot of these will fit. The asymptote here should be at y equals 0, and that's what k is. But then when I try to plot points, I don't have enough to fit. Oh wait, I don't have enough to fit all of them. Oh, I did it wrong. 0 inside. There you go. Now you could change your interval. Like instead of counting by ones going up, you could count by 5s or 10s or something. What's the minimum I would want to see as far as the points you're plotting? What's the minimum? How many points should you? Would I? 3. I think 3 is enough. 4 is better, but 3 is enough. Here I can only fit 2. Do our best. What's the domain? All real numbers. You can put negative. What's the range? You can say y greater than 0, or you can say from 0 to positive infinity because it's going up forever. How about the y-intercept? Where it's touching the y-axis? At 0, 1, you can put y equals 1, that's fine. And where's the horizontal asymptote at? Y equals 0. Ingrid, right? Y equals 0. This next one, let's erase what they're going to put. We'll worry about our own. This is a growth because the base is 3. What's the a here? 1. What's the h? And what's the k? So here there's only one transformation that's occurring. It's a horizontal translation, 1 unit to the left. The way I showed you to graph it, what's starting points did I recommend? For a growth 0 and positive. So let's try 0, 1, 2, 3. What is 3 to the first? To the 0 power. 3 to the first is? 3 squared is? 3 to the third is? So I doubt we're going to be able to fit all of those, but let's see. But we can. Now, all I got to do, like, to get these points that are starting points and turn them into finishing points, is do x plus h and y times x plus h, y times a plus k. But what's really the only transformation that's going to have an effect here? The h. So I can ignore this extra stuff. Leave the y's alone and just add the h's to the x's. So I adds 1. 0 minus 1, comma 1 is negative 1, 1. 1 minus 1, comma 3 is 0, comma 3. 2 minus 1, comma 9 is 1, comma 9. And I'm not going to be able to fit the other one, so I'll just leave it at that. Now, if you see also, just real quick, conveniently, look at some of the points that we're asking you to plug in. Other than the negative 2, because then that would have given you a fraction. The others are pretty convenient. What y did I get when x is negative 1? What y did I get when x was negative 1? 1. What y did I get when x was 0? What y did I get when x was 1? And these are the same numbers you would have got if you would have taken those and plugged them into the function. You would have gotten the same thing. Where's my asymptote going to be at? Y equals 0, because that's what k is. What's my y-intercept going to be? 0, 3. What's L domain of? Real numbers, yes. Range? Yeah, you know what? Let me draw the graph so that people see, because if I just write it down, people are not going to see why it is. So let's just draw the graph. Okay, my asymptote is there, right on top of the x-axis, y equals 0. And then let's put the points. Negative 1, 1, 0, 3, and 1, 9, 1, 2, 5, 6. No, that's still not it. So then, yeah, now we can look at the range since the graph is entirely above the asymptote, and the asymptote's at 0. I would just say from 0 to positive infinity. That's the range. Okay, last one. Is this a growth or decay? Is it A? It is a growth. What's my A here? 1. What's H? 1. What's K? 3. So this only has a horizontal translation 1 to the right and a vertical translation 3 up. Now this also means because K is 3, that I'm going to have an asymptote at y equals 3. Um, if you want to just get these numbers and plug them in for x, be my guest. I like to do it my other way, where I start with parent points and then transform them. So for a gross, I like to start with 0 and positive, so 0, 1, 2, 3. But the difference is now we have a different base. Now the base is 2 instead of 3. So Caleb, what's 2 to the 0 power? 2. 2 to the 0 power is 1. What's 2 to the first power? 2, yeah, not 3. What's 2 squared? 4. And what's 2 to the third? 8. But now what I need to do to these, if I'm going to apply this transformation that we had over here, since there's no A here, A is not going to have an effect. I just have to go to each of the x's and add h, and then go to all the y's and add k. X is positive 1. H is positive 1, I'm sorry. So 0 plus 1, comma, and then 1 plus 3, because that's k. So 1 comma 4. 1 plus 1 plus 1, 2 plus 3. That's 2 comma 5. That's going to be on my graph. You can see why they picked the points that they picked. With 1 we get 4, with 2 we get 5. With 3, 3 plus 1, and then 8 plus 3, that one probably won't fit. But, I did wrong. 1 plus 1. Oh, I skipped 2. Sorry, I skipped 2. Sorry, 2 plus 1, and then 4 plus 3. So that's 3 comma 7. The 3 we get is 7. Now, for some reason, like, you wanted to know what happens when x is 0. we didn't get that from our transformations because to figure out what would happen when x is 0, I would have had to have transformed a -1. But I think you can always just get that 0 and plug it in if you need an extra point. Wait, let me go to the fraction. Never mind. I'll leave it like that. So let's plot our points. 1, 4 is here. 2, 5. 5. Did I add wrong? That's wrong. 5. And then the last one is 3, 7. If you're ever not sure, if what you did was right, you can always plug it in. So watch it. Let's plug it in and see if it works. Try to mess up with my transformations. When I plug in a 1, 1 minus 1 is 0. 2 to the 0 is 1. 1 plus 3 is 4. So that one works out. If I plug in a 2, 2 minus 1 is 1. 2 to the first is 2 plus 3 is 5. And then finally, if I plug in a 3, 3 minus 1 is 2. 2 squared is 4 plus 3 is 5. Dots. Where was my horizontal asymptote? Y equals 3, my y-intercept. Yeah, I'll leave that one because there's no way that we don't know because it looks like it's crossing the y-axis in between two numbers, so we're gonna have to do that algebraically. That's what it is number. Let's do that algebraically. For the range, they're very so domain. Domain's the easier one. What's the domain gonna always be? All real numbers, negative. I really hope nobody gets that wrong tomorrow. And then not somebody not named N. Yeah, perfect. Show me. Tell me what's the range gonna be. Jason, do you know? Range? Say it again? 3. Can't just say 3. Kiara, you want to help him out? Yeah, from 3 with a parentheses to positive infinity. You could also say y is greater than 3. For the y-intercept, we have to plug in that 0. Since they're asking us for a y-intercept, so let's just plug in the 0. See what happens with space. If I plug in a 0 for x, y equals 2 to the 0 minus 1 plus 3, which is 2 to the negative 1 plus 3, which is 1 half plus 3. I'll write that 3 as 3 over 1. What's the LCD of 1 and 2? It is 2. So this is 1 over 2 plus 6 over 2. So it's 7 over 2. And 7 over 2 is the same as 3.5. So you can either put 0, 3.5 or 0, 7 over 2. Any questions on that page? Okay, last page. Fill in the characteristics for the graphs. So at least here we don't have to graph, it's already graphed for us. Jason, what's the domain of number 13? Yeah, all real numbers, negative infinity to positive infinity. What's the range there? Now y equals 0? Yeah. Yeah, from negative 2 up to positive infinity. Or you can say y is greater than negative 2 because Here we have an asymptote at y equals -2. Y is -2, that's the asymptote. There's an imaginary line here that we get close to, but we never touch. Where is this crossing the y-axis? Huh? At the origin. It looks like it's at the origin 0, 0. Read. What is f at -1? What is the value of that function at -1? When x is -1, what is y? No. Anything else? 4. It's 4. And how about the next one? What is the value of x when y is 14? 14. Yep, that looks good. -2. Okay, we know that Jada, all exponential functions do not change direction, so they're either always increasing or always decreasing. Is this one increasing or decreasing? It's decreasing, yeah, it's a decay. So this would be, you just copy the domain and put -infinity to +infinity. It's always decreasing. It's never increasing. Don't worry about this junk. Gotta make sure I didn't show up on the test. And then end behavior. K is for Caleb. What is the as x goes to -infinity, that means left. What's the left arrow doing? Up to +infinity. So up to +infinity. What's the right arrow doing? Going down. How far? It's not going down forever. Yeah, it's going to -2. If you just write -2, that's fine. If you want to show off for all the cool kids, put like a little plus on top, because that's just saying that you're going towards -2, but from the top side. From El Topo. But you don't have to write that. And then for the last one, for the test, Brian, what's the domain here? Okay, good. And I don't even care if you write all real numbers, that's fine with me. How about the range, Brian? You see that going up to +infinity? Going from -infinity, which you would have to write first, because when you do range, it's from low to high. From -infinity up to -1. Martha, Martha, Martha. Where's the y-intercept? Yeah, it's a little blurry, but yeah, looks like -5. That's good. How about L horizontal asymptotal? Where's that at? Y equals -1. Y equals. Ingrid, what is the value of the function at 1? That does look correct. And Ingrid again, what at what input is the output -17? Negative what? 2, yeah. J Money, is this increasing or decreasing, this function? From left to right, if this was a roller coaster, and here was little Jason, going starting at the left and going to the right, would you be going up the roller coaster or down? Huh? Oh, yeah, so this is always increasing. You don't have to worry about this nonsense. And then Marmy, finish so strong. What is the left arrow doing? Left arrow, left arrow, left arrow. Going down, how far down? Negative infinity. Left arrow is going down to negative infinity. What is the right arrow doing? Up to where? Going up to negative 1. If you leave it like that, that's fine. If you want to be even more fancy, it's going up to negative 1, but is it going at it from underneath or is it going at it from above? Coming at negative 1 from underneath or from above? That is it. You can now consider yourself reviewed and you have a test tomorrow.